11-4, normal distributions. Objective, to use a normal distribution. Many common statistics, such as human height, weight, or blood pressure, gathered from samples in the natural world tend to have a normal distribution about their mean. A normal distribution has data that vary randomly from the mean. The graph of a normal distribution is a normal curve. In a normal curve, these things happen. 68% of the data fall within one standard deviation. 95% of the data fall within 2 standard deviations. 99.7% of the data fall within 3 standard deviations. The normal distribution has a symmetric bell shape centered at the mean. Sometimes extraordinary factors affect data that would otherwise be normally distributed. A coin, for example, may be somehow weighted unevenly so that the heads tends to come up more frequently than tails. In such a case, the data would have a distribution that is skewed. Let's take a look at this normally distributed data. Notice that most of the data is in the middle where the mean is, and then there are datas after and before. Let's take a look at a normal curve for a population of male European eels. The mean body length and one positive and negative deviation is shown. So the first one is the average length, 15.7. One standard deviation greater would have a greater length for an eel. One standard deviation less would have less of a length. If we put this in a bell-shaped curve, we would put the 15.7 in the middle. Well, that's where the mean is. One standard deviation, 18.5. Another standard deviation, 12.9. And we can find the other standard deviations by just continuing to subtract 2.8 or add 2.8. Let's take a look at analyzing a normal distribution. What percent of adult American males are between 67 inches and 74.5 inches? You can see that 67 and 74.5, one standard deviation below the mean, and then 2 standard deviations above. So you add those percentages together, and that will be the total percentage that you would expect to find in this data set. In a group of 2,000 adult males, about how many would you expect to be taller than 6 foot or 72 inches? So you can see that we are going to see the shaded area right here. Well, instead of trying to add up all of these little numbers here, what you can see is that it's going to be, you're going to expect to see that this number right here will be the difference between 50 and 34. So when you subtract those two numbers, this will be 16%. So you would expect about 16% of the population to be 72 inches or over. Let's take a look at if we can actually label a normal distribution when we're given the information. The mean is 7. Can you decide where to put that? Standard deviation of 2, can you decide how to label the other vertical bars? And then decide what the percentage is. And this is the way it would look. You put 7 in the middle, go up by 2 for every vertical column, and you know this first standard deviation represents 34%. The next standard deviation under the curve would be 13.5%, then 2.35%. You would add all those up from 7 to 13, and that's the number of percent, the percent probability you would expect to find the value in this data set. Look at the normal curve and see which one of these has been labeled correctly. Select your answer and then click to the next slide. And here's the answer. The others did not use the standard deviation. The first one did not use the standard deviation correctly, and the last one did not put the mean in the right place. Last problem. Let's go ahead and label with the information we have here and try to answer the question. Find the data percent within following the interval less than 47%. And here's the data set. Less than 47 is going to amount to half of the data, and so that'll be 50%.